Oh, yeah. It wasn't recorded, sorry. So we're talking about separable. So in a second, this is example 1, example 2, the y dy dx, dx is equal to cosine x over and then e to the y, something like this. The third one, this is also separable. The third one, dy over dx is equal to y squared x and a plus 1 over x and then y squared. Now here we put one more constraint, x is greater than 0. Because, yeah, so what if x equals 0? Then the right-hand side is not defined, right? So we're going to get big trouble. So I intended to put the restriction so that this one is defined. This is separable too, because y squared is common factor. When you're factoring out y squared, then we're going to get a function of y and a function of x. So this is separable. Okay, so now what? I mean, guess what? We need to learn how to solve the equation, right? So it's simple. Separable, separate, and integrate. So here's a strategy. For solving the separable equation. Okay, we're gonna first one separate. What does that mean? We're gonna completely separate the function of, I mean, all of the functions and terms, everything relating to x, and then everything relating to y. Okay, this is called separate and integrate. Okay. So I see. So see back to the let's look at the example 1. So dy y prime is a dy dx, right? Okay, is equal to 3x squared plus 1 times y. You see that this is kind of function of x, right? And then there is a dx or so something, you know, relating to x, right? So we putting together, putting them together in the left hand side, and then move all of things relating to y to the right hand side, so that we can completely x terms, y terms, so called. Okay, so it implies then dy over y, because I divide by y. I divided by y to move y to the left hand side, and then I'm gonna multiply the both sides by dx to move dx to the right hand side. This is a 3x squared and a plus 1 and then dx. Simpler. So I just separate it. Separated y terms and right, the y terms and x terms. Okay. So now I know. Well, now what? This is separate, by the way. We take integral. Okay. The second step. Let me say it's step 1. Step 1 and then step 2. So integral dy over y. This is nothing but just 1 over y dy, isn't it? Is equal to integral and then 3x squared and a plus 1 and dx. And then now on the left hand side, what's the integral of 1 over y? Well, thank you. And then what? Absolute y. Don't forget the absolute value. And then plus, this is indefinite integral, so we got c, right? Let me say c sub 1. This is equal to, what's that? Huh? 3 plus c, right? C is, this is sub c sub 2. Okay. Now, yeah, I know. Okay, is that all? Is that answer? Yeah, you can say that, but please simplify the solution so that we get the explicit form of solution if it is possible. So I'm gonna move to C1 to the right-hand side to combine C2, because normally we don't write the multiple constant integrations in the one equation, one solution. So I'm gonna combine this one, C1 and C2. Okay, so let's say move to the right-hand side. So let's say C is equal to C2 minus C1. Actually, the sign of C doesn't matter because the value of C, including sign, will be determined by initial condition. This is a really important point. Don't get too much caution of the C1, C2. Don't, because C1, C2, combining them, you can say C is a C2 plus C1, doesn't matter. Or you can say C2 minus C, doesn't matter. Or you can put minus C, doesn't matter, because C will be determined by initial condition. Because the initial condition is not here, so we don't know what C is. That will determine by initial condition. So even if you put the negative sign right there, the sign of the negative C will be determined by initial condition. So now let neutral log absolute y is equal to x cubed and then plus x and then, yeah, plus C. Okay. All right. So, and then what? Absolute y is what? Is y is equal e to the, right? X cubed. Let me say, yeah, e to the x cubed plus x plus C. Okay. This is equal to e to the x cubed plus x times e to the C, right? Okay, now let's say this is a C. Okay, sorry. Let me say this is C3. Then let's say this is C. So many C, right? Okay. So many C. Don't worry, that's not your grade. So okay. Okay, so now you see that? Let's say this is a C, okay? So now we've got the C times e to the x cubed plus x. C times. Okay. You got it? You follow me? I just want to make sure that we're on the same page. So C times e to the x cubed plus x. But you know what? Okay, how can you take out the absolute value? Yeah, that's right. Because the exponential function is a positive for any value of exponent, right? So this is always a positive. I know C may be negative, but anyway, this will be determined by C. And actually look at the C. C is e to the something, right? They must be positive. This is positive. This is positive. Positive times positive is more positive. This is greater than 0. So we don't need to actually put absolute value. So it's y is equal to C times e to the x cubed plus x. Okay. Okay. Yeah. Wait a second. Oh yeah, I think I made a mistake, right? So we doesn't matter that we have to put the plus minus sign. Yeah. Yeah, right. Oh no. Yeah, so we said this one is equal to UC. Let's say A. So this is equal to A times e to the x cubed plus x. Sorry. That's right. Yeah, you can do that. Either one doesn't matter. Yeah, either way doesn't matter. Yeah. So now you see here, this is A. Yeah. Okay. The thing is that you don't have to try to figure out sign of A because the sign of A will be determined by initial condition. That's the point. Okay. So now next one. Linear equations. Okay. The one of the strong suit, one of the advantage, or we can say strong suit of this separable is that as long as the differential equation is the separable, we can use the method of separable, whether or not this is a linear or non-linear. That's a really good thing. Next one is the 2.3, right? 2.3, the linear equation. Equation. Give me a second.